Alright guys, welcome to Unit 2 Quiz 3 Study Guide. I'm going to go ahead and go through 1 through 4, and then I'm going to do probably all the even problems down here, and I'll leave the odd ones to you guys for extra practice if you want to, with an answer key included. So let's go ahead and begin with 1 through 4 here. So the first thing we're going to do is we're going to integrate all these things. So if I integrate this piece, I'm going to end up with f. And if I integrate the next piece, I get the g. And the 3 is just, the 3 and the 2, they just kind of stay there. And my limits are -1 and 1. So the first thing I'm going to do then is I'm going to plug in 1. And then we're going to plug in the -1. All right, then we just use our table to figure out what these values are. F of 1 is -1. G of 1 is also -1. And f of -1 is 5. And g of -1 is 3. So we have -2 plus 3 is 1. And we have 10 minus 9, which is 1. And final answer there would be 0. So there it is. So just go ahead and do the integration, plug in your limits and subtract them. Fundamental theorem of calculus. You're good to go. Let's go ahead and take a look at number 2. On number 2, we're going to be using Usubstitution for this type. I'm going to let my u be equal to the g function. And therefore my derivative of u with respect to g is going to be g prime of x. Actually, it's not with respect to g, it's with respect to x. Let me back up a little bit. There we go. And then getting the dx by itself, we're going to have that. And then doing our Usubstitution, we're going to have f prime of u instead of g in there now. And we have our g prime of x, and we're going to be replacing the dx with du over g prime. And as a result, those cancel out. And so we have a simplified expression there. But we also need to change these limits. Okay, those are x values, but I want u values. So since u is equal to g of x, and I know that the x value on the top is 1, I can just plug 1 in and figure out that the g value of 1 at 1 is going to be -1, so that means that u is equal to -1 at that point. Next, we could do the same thing with the bottom. We could plug 0 in, and g of 0 is 2. So there's that. So after all my u sub is done, we have this simplified expression here. Okay. When we integrate f prime, we get f. And then we go ahead and do our fundamental theorem of calculus. So I've got f of -1 minus f of 2. F of -1, according to my chart up there, is 5. And f of 2, according to my chart up there, is -1. So 5 minus a -1 is 6 would be my final answer. So basically we're going to do it, for these types of problems, we're going to do a u sub where the g of x is your u. All right, let's go ahead and move on to number 3. It's another u sub problem, but this time your u is going to be the 2x, which means that our du is going to be over 2. Do our little integral here. So we're going to have g prime of u, and it's going to be du over 2. We also need to change our limits. So for that, my u is equal to 2 times x. And for the top limit, I'm going to plug in 1 to get 2. And for the bottom limit, I'm going to plug in 0 to get 0. I'm going to pull this 2 out to the front so I have a half. And now we have a simplified expression. We're going to go ahead and integrate the g prime, which is going to give me g. And then we're going to go ahead and apply the fundamental theorem of calculus. So I'm going to have half on the outside, and we're going to do g of 2 minus g of 0. And according to my chart up there, g of 2 is 0, and g of 0 is 2. And so that leaves me with negative 2 over 2, which is negative 1. Final answer there. So once again, just another u sub problem, but this time my u is 2x. Let's go ahead and take a look at number 4. No u sub on this one. It may have u sub on your quiz, I don't know. If you have something else other than x on the inside here, it'll be a u sub. But the point, what makes this one interesting is the fact that it's a double prime. Because when you integrate a double prime, you get a single prime. Since I'm not doing u sub on mine, I'm not going to be changing the limit. But like I said, I don't know on your quiz if you end up with one like this, whether or not it's going to be a u sub or not. But anyway, so we have f of 2, f prime of 2 I mean, minus f prime of 1. And so f prime of 2 is 1, and f prime of 1 is negative 1. And so final answer there is going to be 2. Final answer. So those are your FRQs. For these types of things, basically, you're going to get 1 point for the integration and 1 point for the final answer. So showing your work for the u substitution, if there is any, or just the integration, is going to be worth 1 point, and then actually working it out to the final end is going to be worth the last point. So 2 points altogether for FRQs. Let's move on to the next set down here. So for these guys, I'm going to do all the even ones. So let's go ahead and start off here with number 6. Now at number 6, the first thing we want to do is separate our variables. So I'm going to multiply this cosecant squared of y to both sides. And I'm also going to multiply the dx on both sides. And that's my separation of variables there. The next thing we're going to do is we're going to integrate both sides. Okay, so the integral of this guy here ends up being negative cotangent of y. The integral of this guy is going to be x squared minus x plus c. And then after that, we want to get the y by itself. So the first thing I do is I'm going to divide everything by negative 1 to get rid of the negative in front of the cotangent there. You don't need to change the sign in front of the c because it's just an arbitrary constant anyway. But I do want to get rid of that cotangent. And the way that we do that is we do arc cotangent on both sides. So that gets the y by itself on the left, and then we're going to arc cotangent this side. And that will be our final answer there. All right. Let's go ahead and take a look at number 8. So numbers 7 and 8 are problems where you want to split the numerator. So the first step is going to be to do that. If we split the numerator, it's supposed to be a negative. Let me fix that. It will look like this. And then after that, we're going to simplify. So this just becomes 1 over x. This, I'm going to rewrite it as 8 times x to the negative 3. And then I'm just going to integrate them. The integral of 1 over x is ln of x, absolute value. This integral is going to be 8x to the negative 2 over negative 2. You add 1 to the power and divide by that value, you put plus c. We can simplify this a little bit. First of all, these negatives cancel and it becomes a plus. and this guy can go to the denominator. So if I do all that fancy footwork, which isn't necessary on a free response question, then you're going to end up with the following. And this test is not, this quiz that's coming up is not going to be a multiple choice one. So it would have been okay for you just to stop right here, just so you know. Let's go ahead and move on to number 10. So these are the kinds where you want to be doing some long division. So we have x cubed minus x squared plus x minus 1, and then x plus 2 on the outside here. All right, so x times x squared will give me x cubed, so I know that x squared is going to go here. And I'm going to multiply that times both of those to get x cubed plus 2x squared. Then I'm going to subtract those. Those cancel, leave me with 3x squared plus x minus 1. Now I'm going to multiply x by negative 3x to get this. So that's going to go on top, negative 3x, and multiply that by both of those. Get negative 3x squared minus 6x. Change the signs. Finally, x goes into 7x 7 times, so I'm going to put 7 up here. And then I'm going to distribute that in, and I get 7x plus 14. And then we change the signs. That goes away, and I'm left with negative 15. All right, so now we have our function rewritten. So it's x squared minus 3x plus 7 plus a negative 15 over x plus 2. All right. So if I integrate this guy, I'm going to get x cubed over 3. If I integrate this guy, I'm going to get 3x squared over 2. If I integrate that guy, I'm going to get 7x. And this guy, we have a shortcut for that, right? If you were gone on I think it was, what was that, Friday, I shared a little shortcut. I'll review it with you here. I did it earlier in one of our other videos for this weekend, but just in case you missed it, I'll write it again here. So anytime you have a function that looks like this, the integral is going to be this number over this number, ln of the entire denominator. Okay, so you could solve this integral by doing Usubstitution, where the u is the x plus 2. But it seems to happen a lot, and so it's nice to have a shortcut for it. So we have this number over this number, which is 1, so I could really just write 15. ln of the absolute value of the bottom. And we don't want to forget our plus c, and there's our final answer there. So let's go ahead and move on to number 12. That's our last problem. Exponential problem. So in that case, our u is going to be the power. My derivative is going to be secant squared, and that's going to end up going on the bottom. So doing my u substitution, we have secant squared x, e to the u, du over secant squared x. Those go away, and now I'm left with this. And the integral of e to the u is just e to the u plus c. Finally, putting the u back in, we have our final answer. All right, so you can expect to see the following on your quiz. Once again, the quiz is not multiple choice this upcoming Wednesday. You're going to have one of these FRQ type questions, and I'm only calling them really the whole test is FRQ this time because there's no multiple choice. But I'm calling these FRQs because these were our FRQ practices over the weekends that we did. So you'll have one like one of these, and then you'll have one of these, one of these, one of these, and one of these. It's a total of 5 problems. So you'll have one of each of those 5 types. Okay, and that'll do it for this study guide help video, and we'll see you guys in class.